Yeah.
She could pick and I memorized all four of them.
Yeah, that's all I can say.
I was having it for hours.
Oh, wait, today, this is my last academic class besides
Well, if you really count no, I have to.
Oh, you have Mr. Bradley? I just asked you, so yeah, you're fine. Oh, you're in Dan's class.
Yeah.
Yeah. No, it's so easy. It's so free. You're so free. You're with a dog.
All right, let's get started with the do not first, and I'm gonna come around and check your homework, so I'll also have that out, the usual routine. If you could just please, we're gonna skip the last one, but for those of you guys who want to actually try this and want to get an answer out of it, I'll tell you. But I'm only gonna check this number 1 and number 2, okay? Because the reason for that is because I don't want to spend too much time talking about the third one. Third one is a really good question, okay, and it's very challenging. And we'll get to it. If I at the very least, I can put that on the study guide, and I'm going to go over the answers with you. Okay, but 1 and 2 for now. Okay, because I just want to see that your knowledge of arithmetic series is at least there for like example like number 1 and 2. Number 3 is really it's tough, and it's gonna be once you figure it out, that's great. But well, anyways, just homework out in front of it. Is Owen here, by the way?
No, he's virtual.
I'm on Zoom.
Oh, like for the rest of the year?
No.
Oh, just 2 days.
Yeah.
Yes, he is. He's right here. I see. Did you guys hear about yellow phase happening?
Yeah.
It looks so complicated.
Yeah. No, it's just it's 8 days except for 8 days.
Right, but it's no. It's A B, B C, A C.
Yeah, it's so easy. Like if you think about it.
With that, you have day 1, day 2, day 3, day 4. So 2/3 of you guys will be in school, while it's 1/3 of you guys. No, that's not what I'm saying because I don't know.
Wait, so they're still keeping. Oh. So then.
It's hybrid, but with more people in. Yeah, instead of being 50-50. Yes, that's basically how you want to see it. Yeah.
Then is it going to be 3 days 1 day round, 3 day 2, or is it going to be 1?
Remember the usual schedule we did when we rotated and like it was 1, 2, 3, 6, 7, 8.
Yeah.
It's most likely going to be like that.
No,
Back to Deriving.
no, that might mean on day. Yeah, that means day 2, no math.
Yeah, on certain days you will not have math at all. But on certain days when you have math, you won't come into school because it's like you divide into those groups. So
We really just have to see how many different schedules they can throw at.
it's already complicated as it is. Why not make it more
I
complicated?
only thought they were doing like A, B, B, C, C, A. I thought they were just doing that and then keeping like the 1, 2, 3, 4, how they're doing it. This is a little more complicated than I thought. Oh, you did the one that was original. There was 2 more questions. But it's fine. But is it a lot? Yeah. And when you're bringing on bottom, the A's of N is 1. Moving on to the cognitive is common.
Oh, okay.
30. Wait, the 14 or 30. And then we have the 30. All right, let's one down. Okay. What is it on? What is it?
Answers back in
Doesn't even.
And
You know, I can take it.
No one cares about. Who was it do before him? John? Yeah.
Tyler.
John Tyler. No one cares about him. Is he a top 5 president of all time? Clearly. So no one cares.
Who are the top 5 presidents of all time?
George Washington's got it.
Washington.
Abe Lincoln.
JFK.
Put it this way, if you're not on Mount
JFK is
Rushmore,
not a good
you're not like
person.
JFK or somebody else.
We had like 10 different affairs. We would have had more if you didn't stop.
FDR should be on there.
I mean, that's true though. I had to do a research project on JFK for marketing.
Uh-huh.
And I learned about a lot of different women that he had affairs with.
Oh, really?
I don't even remember all their names. I just know Marilyn Monroe, his secretary, and a couple of others.
A couple of others.
I do know he was the first Irish American president.
Oh, that's interesting. Us, really?
though. Yeah.
First
That,
Irish.
I had learned that before researching because in Umbrella Academy, in the Netflix show, they said
Oh.
something about that.
Oh, I
So I
see.
remembered that, and that's kind of like the reason I chose it, because I'm a bit Irish myself.
Oh, I see. I see. I
I
see.
have pride.
Did you have to like research on one of the presidents?
Yeah, we had to research like famous people from decades in the past and we'll find different products that they were.
Ah.
Oh.
I did him and Nixon. So those were two interesting ones.
Oh, John Lennon.
I think about
Oh, yeah.
From yesterday, the summation formula, as you know, it's n divided by 2, a sub 1 plus a sub n. Don't forget that. That's the series formula. I gave you a little history lesson yesterday. So very small, brief overview of where this, I don't know if this formula was originated from that story, but it's definitely related. First term plus the last term times n divided by 2. Okay. The first one might be a little bit more difficult than the second one, but hopefully you guys have, you know, some sort of an idea as to how to approach this at least, as to where to start. You need 3 things always whenever you guys are doing this. You need a sub 1, you need a common difference. You don't need it for summation because there's no d, but you do need it for this problem. You do need it to solve this problem, yes. Because I don't know what a sub 1 is, nor do I know what a sub n is. So I do need the common difference. Well, you do know what the common difference is. Because if they give you the 10th term is 17 and 14th term is 30, that means when you move 4 units, you know, four more units upwards, you will go from 17 to 30.
But it's an odd number to an even number.
13. So if you don't have a calculator by your side, I'm assuming you're really good at mental math, like I said yesterday, or you're not doing something right. That's what I told you guys.
Well, I don't think I'm
Once you have the common difference, I believe we can all solve for the first term and the last term. You can use explicit formulas. At the end of the day, find out the summation of the first 30 terms for me. All right, let's do this. All right. So first, can someone tell me what common difference was? I think I heard it, James.
3.25.
3.25. I like that. All right, so 3.25, you keep on adding that and you go from 17 to 30 in a matter of 4 units upwards. All right, so now if you kind of think of it backwards, if the 10th term in the sequence was 17, so yeah, absolutely. So here, the ace of 10, which is 17, that is the first term in the sequence, which we still don't know. But the common difference here is plus 3.25 times n, which is 10th term in the sequence minus 1. Okay, so at the end of the day, what you're going to get is the first term is just left completely by itself. So in other words, you do 3.25 times 9, because that's 9 more terms in the sequence, and you subtract that away, 17 minus that, and I believe you get negative 12.25 for that one. Okay, because if you do that all, move it all to the left-hand side, you get your first term. Yes, Kate? Ace of n is something called the last term of the sequence. Okay, so in this case, I really shouldn't use something called ace of n because they told you what n is, which is 30. So I should probably say ace of 30 instead.
Yeah, and then you would use 14.
I would use, you mean this being 14th term? Nope, I won't use that at all, because since now I use this formula to figure out what the first term is, right? So since I already know what the first term is, I could just use the arithmetic formula once again, saying that, okay, I want to figure out what ace of 30 is, right? Well, ace of 30 is the first term in the sequence, which is negative 12.25, since I already figured that out, plus the common difference of you keep on adding 3.25. Well, how many more times do I have to add it? 30 minus 1. Because I have to start from the very first term. If I add the common difference 29 more times, I get my 30th term. Okay, so it's all a matter of, see, I'm really pushing this really quickly for you guys. I am this is a tough question because we just talked about series yesterday, and I didn't, quite frankly, I don't think I gave you enough practice with this yet. But the reason why I'm pushing this a little bit quickly is because we still have to get through geometric series, which we're going to get to today. And trust me, when we get to the study guide, you guys will be feeling much more comfortable with doing these types of questions. Okay, but you guys get it now, right? It's tough, but you guys.
So when I'm finding the sum for 30,
Yes.
so I'm plugging in x of 30, right? Equals 30 over 2.
Yep.
In the parentheses would be negative 12.25
Plus whatever this gave me, because we found out the 30th term of the sequence was this, right? So I'm gonna use that in my calculator. I'm gonna do negative 12.25, and I'm gonna add that 3.25 times 29, and I get 82 for this. I just use the explicit formula to get 82 for the ace of 30. So then I put 82 for this one. Let the calculator do the work. Negative, subtract minus 12.25 times 15. My final answer for summation of the first 30 numbers is 1046.25. Like that. Your foundations for the explicit formula needs to be strong, okay? There could be different various variants in which how I can ask your arithmetic sequence. But at the end of the day, you are using that formula, explicit and the series formula there. Does anyone have any questions about this? It's okay if you ask me now. Like there's no, I mean, this is tough stuff. Yes.
Still don't get what you got.
You still don't get, you mean the 82? 82, okay. So do you get how I got ace of 1 though? Because if you understand how I got this, you should, this is even easier to understand. Okay, so let me start from ace of 1 though. Okay, the only clue that they gave me in this particular question were these guys. The 10th term was 17 and 14th term was 30, right? Quite frankly, that is enough to figure out the common difference, which I think you found that as well, right? 3.25. Okay, so you have the common difference. Recall your explicit formula, Chris. It's ace of n is equal to, can you recite it for me? The first term plus the common difference times what goes
3.25
plus 3.25 times what goes in the parentheses? Do you remember? What is it? N minus 1. Okay, so what I did here is that I just took, well, the first term was what I was trying to look for, right? But you kind of plugged in already. But let's say that you don't even know what the first term was. Okay? You don't know what the first term was because I'm trying to start from the beginning. You're only given these two information at the top. 10th term is 17, 14th term is 30, right? So what I can do is I can still say that this is a sub 1. Yes, James?
Plug in 2 for n, and then only do 1, or when you plug in 1.
I need you to take a look at the 10th term in 17 is like this. When n is 17, when n is 10, that means a sub 10 is 17. That's what this is talking about. When n is 14, a sub 14 is 30. That's also another way to look at this sentence right there. It's up to you. Pick one you want, but let's say I use this one and plug it into your explicit formula down here, because the only thing I know right now is the common difference is 3.25. So let's say that I do a sub 10. A sub 10 is 17. I don't know what a sub 1 is, plus 3.25, but what's the n value? 10 minus 1, which is 9. So 17 equals a sub 1 plus 3.25 times 9. 3.25 times 9, that's 29.25. Am I losing you, Chris? No? Okay. So a sub 1 plus 29.25. When you move that to the other side, which I don't have space for, but you get what I'm saying. I move the 29.25 to the other side. So I do 17 minus 29.25. I should get this, negative 12.25. That's where this a sub 1 is coming from. Okay. So now that I have the a sub 1, then it's pretty simple. Then I go back up here. Instead of saying a sub 1 in letters and without being any clear numbers, now I actually have it as negative 12.25. See, what I want to solve for is now a sub 30. So I put 30 here because that's the last term in the sequence, which means I'm going to substitute 30 for n right here, which then it becomes numbers. And at the end, when you put this in the calculator, like I said many, many times, let the calculator do the work, 82. I have 3 components. I have those 3 ingredients that I can cook with. I have everything I need. Plug and chug into the summation formula right up there, and then you should get 1046.25.
Mr. Kim, could you just zoom out so like I can see the?
Sorry, I didn't give enough space for this. It's because I should have deleted the third question here, but that's what this is about here. All right, today's lesson is gonna be challenging, guys. You're not gonna be doing a lot of like practice problems today because unfortunately I have to elaborately describe to you because we're gonna be talking about geometric series. Yesterday I showed you a little history lesson with arithmetic series, right? I hope that kind of you caught on to that as to where the formula came from. I'm not the type of person to kind of throw the formulas at you. Sometimes I do, but not in these type of cases. I want you to know where it came from and how it came to being. How does this actually work? That's what I want you to know for geometric series. For arithmetic series yesterday, I hope you guys all found it easy. For geometric, if you think about it, how am I supposed to find the summation of numbers that's actually getting multiplied? It's a whole new story, okay? Yeah. Number 2, find the sum. Wait, Owen, are you okay with this so far, by the way? If you don't mind, I'm just gonna move this down here. Okay, and I'm just gonna work on the second problem. Find the sum of the positive terms of the arithmetic sequence 85, 78, 71, blah, 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 1. Here, let's see. Maya, what's the common difference that you can see?
7.
-7, right? We keep on subtracting -7s each time. See, as I've said to you earlier, if I'm trying to find series, I need 3 components, n, a1, an. I believe I have the first term. I also believe I have the last term. The only thing I'm missing is what in the world is that n value? Okay. Again, what do I use? You use explicit formula once again. So the explicit formula tells us that the very first term is 85 minus the common difference 7 times n minus 1, which we still don't know. The very last term in the sequence, we don't know, but that a sub n is equal to 1. The a sub n is equal to the first term minus the common difference of 7 times n minus 1, which also happens to equal 1.
So we do 85 minus 7 first.
No. You gotta. It's like this.
Oh, right, add 7 to each side.
Okay. Let me. 3 equals 4 minus 2x.
I'm gonna take away 4.
Yes. Think of it that way, please. That's what happened here. Let's
85 first.
subtract 85 first. Okay. So we're gonna subtract 85 on both sides of the equation like this. So it's negative 84 equals negative 7 times n minus 1. Then what do I do next,
And
Christian?
then you divide 7 by both sides. with-
Divide by negative 7 on both sides.
7 by both sides, and then you get n minus 1 is equal to 13.
And then so what is n gonna be?
N is then 12. Or
No.
14.
14. Thank you.
Wrong addition.
Yeah.
Wait, 84 divided by 7 is 12.
And it's 13.
Oh, I'm sorry. Yes.
Oh, wait, it is. Oh,
That's
yeah.
12 and that's 13. My fault.
That's all.
Now we're good?
Yeah.
Yes, I believe we're good now. All right, so now I have n, a1, an. Now you plug it into the formula for the summation, which states 13 divided by 2 times 85 plus 1. Nice numbers to work with. So 86 times 13 divided by 2. My final answer here, 559. That's the summation.
That's the problem.
Yeah, that's the summation of those numbers there.
Definitely simpler than it was.
That's, what do you mean by simpler?
It's much easier to do.
Uh-huh.
And I think I understand more how to actually plug everything in
Now.
on my own than I did. Yeah.
Before.
the beginning period.
Yes. Okay. That's all I want to hear. Yes, Chris.
I was looking online last night.
Yep.
I saw the n/2 formula. I saw something different that had to do with d. It was like n/2 times a1 plus n minus 1.
Can you start that from the beginning?
n/2 times a sub 1 plus n minus 1 times d. And it still gives me the same answer. It's
You-
2a.
2a1.
my bad.
Yeah, that's the same thing, because what you basically did was you take my formula. Okay, that was my formula from yesterday, right?
Yeah.
You substitute what we call the explicit formula to here, which states a sub 1 plus this common difference times n minus 1. So that's why you have two. I don't have space here. I'm gonna erase all this. Quite honestly, for number 2, I would much prefer to use my equation because there's no purpose of this. Maybe the second equation, Chris, that you mentioned applies to the first problem because you have common difference, right? So here, the reason for that is n divided by 2 a1 plus the a sub n. Well, the a sub n is same thing as saying a sub 1 plus common difference times n minus 1. That was what we talked about previous week. That becomes 2a sub 1, and then the rest is the same as what you just told me. So it is the same thing. Okay. But anyhow, this is a lot of stuff on the problem set. But number 1, 1046.25. Number 2, 559. Okay. Yes. Next one.
There's 3 and equals 24.
Yes. Great job. Well done. Okay. Like I said, number 3, I will give it to you guys later on. But first, let me talk to you about geometric series. As I want to expose to you to both cases, both way, like arithmetic and geometric, and how it came out to being. I don't have that much time with you, so after that, I'm going to give you maybe like 1 or 2 practice problems, and we're going to call it a day. Today, I need you to be ready when I give you a question like this, because you know I like open-ended questions, right? So from yesterday's lesson, how do we derive the arithmetic series? Like, how would you be able to describe that for me? What did we do yesterday?
Let's us find the summation of all the numbers in
Specifically arithmetic.
yeah.
Arithmetic sequence, right? So let's say that you got this question on the test, and let's say like, oh, you're trying to like kind of prove it. You can pretty much use the example I provided for you yesterday. Like, let's say you do 1 plus 2 plus 3 plus blah, 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 98 plus 99 plus 100. And then what do? We took the first and the last number and we added those together. We got 101. The second to the second highest number, we got 101. And you find that the pattern is the fact that when you add the first and the last numbers together every single time, so we say a sub 1 plus a sub n, it's the same thing, but you just have to multiply by the pairs of how many 101s you get, which was n over 2. Okay, so that's in logic, that makes sense to you guys, I hope. Okay, and I hope that's how we derive it. Yes?
If say we had this on like a quiz or a test,
Yeah.
would we actually just like draw that rather than describe it?
Yes. Yes. Honestly, that's what, because I can't guarantee you how long it's going to stay in your brain once once you are done with algebra 2 and move on to honors algebra 3. But I want you to still tell it to me, at least for my quiz, as long as you were in my class, where this formula came to be, that you did this before. Not that I just, Mr. Kim, threw this at your face, that you actually know where this came from. And the same thing is true for geometric series. Today, we're going to look at how we can derive geometric series, and I need you to be ready for this. Unfortunately, I don't have that little funny, the history lesson for this one. I need you to write this on your notes as much as possible. There's going to be a lot of math here. And so here we go. The summation of geometric series, we're going to call it S of n, is equal to, if you think about it, any geometric sequences that you could think of. 2, 4, 8, 16, 32, 64, blah, 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 blah. They all kind of look like this. You have the very first term in the sequence, plus the first term in the sequence times the common ratio r, plus the previous term, like recursive formula, and you multiply that with another r, so make that r squared, plus a sub 1 r cubed, plus blah, 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 blah. That's going to keep on continuing until we get to a sub 1 times r to the power of n minus 1. Why do we get this? Well, that turns out to be the same thing as the explicit formula for geometric sequence, which is a sub n. So that's the first term and the very last term, and you're just going to add them all up. That's what series is about, right? Now that looks complicated. Okay, that's not something that you can type in your calculator. So what you're doing is you're literally typing this in. 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus all the way down the road. But nobody has time for that. Yes, Kate?
Wait, that's how you derive the geometric series?
Well, we're not done. That's how you start. Okay. Kate, can you tell me though, there's a term that's in common in every single one of these terms? There's something in common. What do you see? A sub 1. So why don't we factor that out from the very beginning? And what am I going to get in the parentheses here, Kate?
R squared, R cubed, and then R n minus 1.
Plus all the way to r n minus 1. But can you please tell me what I should start right here in the beginning? Because if I factor out a sub 1 from here, what am I left with?
1.
Yes. 1 plus r squared plus r cubed plus r blah, 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 to the power of r to the n minus 1. Okay. Still doesn't really do much for us. This is a lot of work. I don't know how to make this into a really nice formula. And we're going to put a small pause button here. And then I want you to take a look at this for me. This is going to be tough, so bear with me here. Okay. I know it seems complicated. I just want you to forget about all of these things down here. Forget about this, and I just want you to focus on this because we talked about this way back in October/November. Can someone tell me what the answer to this is? If you expand it?
R cubed plus
Wait,
1.
what is it?
Isn't it R cubed?
No,
Neg-
there's only 2 r's here.
Negative.
R squared, thank you. R squared minus 1. Well, instead of saying, but first of all, I put 1 minus r, 1 plus r. So that's not r squared minus 1, is it? 1 minus r squared. We gotta flip it over. And you guys can FOIL. First outer inner last tells us that if I still do 1 times 1, that's 1. That's 1 times r, which is plus r. That's negative r, which cancels each other out, and minus r squared. That's quadratic stuff that we've been dealing with before, okay? So far, are you guys with me? No. Yes, not right now, yes. But it's not really that bad once we look at the patterns. Now let's take a look at the second one. Okay, and then I want you to see for yourself as to what you're going to get. I'm going to FOIL it out for you. Ready? 1 times 1, that's 1. 1 times, yes, please. 1 times plus r is plus r here. 1 times plus r squared is plus r squared, like that. So that is the first component that I do when I distribute 1 to each of those terms. Then when I take the second term and I multiply to these three things, take a look what happens. I get minus r, that's negative r times 1. Negative r times r here is minus r squared. And the very last one that I get is minus r cubed.
It's just 1 minus r cubed.
Yes.
Oh, let me guess.
Yes, I like that. Let me guess. Please guess. What is it?
It can be 1 minus r to the 4th.
Yes. I mean, you could spend your time to actually distribute this out, but you will be able to cancel everything that's sandwiched between the first and the last term. And you will get 1 minus r to the power of 4. Now, why am I bothering you with this is that because if you keep on continuing down that list, r to the 5th, can you guys all see that too? 1 minus r to the 6th. My question is, what is that last thing going to be?
1 minus r to the power of n.
Yes. Why? Because here's the pattern. Look at this last number and look at the number here. Here, that's power of 4.
You just add 1.
You just add 1, 5, and 6.
That cancels out your 1, right?
That cancels out with your 1, so you just left with n here, right? You guys all see that?
Oh my gosh, actually, it kind of makes sense.
Okay. So now why am I bothering you with this?
No idea.
Is because remember in the beginning when I pressed that pause button, what Kate just told us when she factored out a sub 1. This right there is that big parentheses what we got. Remember when we factored out a sub 1, 1 plus r squared plus all the way down to r to the n minus 1? That entire thing can be summarized like this. If you divide both sides of the equation, because you see how 1 minus r is still being multiplied there, let's divide both sides by 1 minus r like that. This right here, even though it doesn't really look like it's going to be equal to that, it is. Because after all we've been through with the first 5 examples, that will work. This entire thing can be represented as 1 minus r to the power of n over 1 minus r. So if we go back up to the summation, which was here, this, when Kate factored out a sub 1, that can be represented as 1 minus r to the power of n over 1 minus r. So the summation of the geometric series is a sub 1 times that entire thing. This is how we write down geometric series.
That's just because you can divide the 1 minus r on both sides.
Yes, from this example, right? We divided this 1 minus r to both sides of the equation.
Yeah.
Right? And we saw, why is it 1 minus r to the power of n? Well, we just add 1 to that last term there, just like James told us. Okay? So this is that really nice textbook. You type in geometric series formula, and this is what's going to pop up on Google. Okay? There's one more formula, but that's called infinite series. That's a little bit different. But this is finite geometric series. Okay, and it's pretty neat. And we're going to put this to the test to see if it really works or not, because I had quite doubts as to how in the world in this entire looking complicated thing going to be represented as really nice, clean looking thing. 1 minus r to the power of n over 1 minus r. All right, so let's take a look at a couple of examples. To sum up, you have already written this down in your notes, I'm pretty sure. You don't have to write this down. That's particularly because if you plug in 1, you get an undefined solution. So you don't really have to worry about that. You need 3 ingredients like the arithmetic series. Those are the first term, common ratio, and the total number of the sequence. If you're given those 3, you can always find out the summation of geometric series.
Mr. Kim, why does r have to not be equal to 1?
Because imagine what happens if it equals 1 and you plug it in right here. Then you got to do 0.
Oh, then it's undefined.
Then it's undefined, right? And if you think about it, geometric sequence, if the common ratio is 1, like 2 times 1 is 2, then times 1 is 2. So it's like you're looking at like
Yeah,
this.
it doesn't make sense.
Yeah, it's like it's not like geometric. Well, it's kind of like geometric series, a sequence, but it's really dull. Well, we'll talk about these guys too. There's really not that much of a, exciting thing happening there. All right, I want you to take a look at number 1, and we're gonna work on number 2. You guys are gonna work on number 2 by yourself, and that's gonna be it for today. Okay, so let's push through for the last 5 minutes strong. 2, 12, 72, 432. Charlotte, can you tell me what the common ratio is for this one? 6. The first term is 2. And remember, I told you there are 3 things I need. I got my first term, I got my common ratio, and the total number of the sequence. Well, we are just going to have these 4 terms. Okay, so the n is 4, guys, okay? Now, before you type this into your calculator, I want you guys to do the following. Can somebody please do this for me? 2 plus 12 plus 72 plus 432. Yes, James?
I got 518.
518. So that is the summation, the finite summation of this geometric series, yes?
I did it right.
What's up?
I tried to do it, and I think I got 518.
So you got 518 by just adding these, right?
Yeah.
Okay, great. Now let's use the formula to see if I do get a 518 or not, to see if it really works. It should. It should. So, but the problem is sometimes what I've seen is that some students do not plug this right into the calculator because you have exponents and things like that. So here's how I want you to type it in. The formula says a sub 1 times 1 minus r to the power of n over 1 minus r. So you're going to say 2 times 1 minus the common ratio of 6 to the power of 4 all over 1 minus 6. Please type that into the calculator.
Wait, can you put like a sub 1 on the outside, right?
Yep.
Okay.
Wait, so n would be how many terms you have?
N is always the terms you have. In which I'm hoping you guys get the same exact number as James got. So that verifies that this formula will work no matter what. If you're done with the first one, could you guys please work on the second one on your own? Verify, please, for yourselves. Add them up. Get a number. And then use the formula. And then try to see if they actually do get the same thing. Yeah.
I think I derived a different way, but I'm not sure.
This became a question.
And then you subtract them and get here.
And 1 minus. That also works. There are different ways in which you can solve for that. If this way, you will get the same thing you promised here, but the only question is, after you got to this, how did you get to this?
You subtract.
Oh, you subtract. So everything cancels out, and only this and this go down. Excellent. Absolutely. That's it.
Okay.
That's also another way to do it.
I have a question about number 2.
Number 2, yes. What's up?
Would it be plus 5, right?
The common ratio?
It would be 1 plus 5.
Negative 1 plus.
Yeah,
Oh, so it's
negative 1 goes in for a minus 1.
Yep. Negative 1 times 1 minus.
Wouldn't it be plus 5 since it's
No. It's negative 5 in parentheses. This is why I was very scared. You gotta put negative 5 in parentheses like that and raise to the power of 4, because PEMDAS tells us that we gotta do powers exponents first.
Instead of multiplying by 1.
That's right. Or multiply by negative 1 for that matter. And then you do 1 minus negative 5 like that. So you should get a positive 6 in the denominator. That's no questions asked. But for the top, make sure the calculator allows itself to do that first. And you will know you will do something wrong if you do not get 104. You gotta get 104 when you type this into the formula.
I don't know why I get syntax error.
Can I see?
The negative signs, next to the period.
Right, but what did you type? You just type in one more time. power of 4. Yep. Let me see. Okay. When you do minus, you gotta do a minus sign. Not press enter. There you go. Yeah. So, and then you do -1 times that. Right, because you. Or then we can multiply by -1. It's up to you. Yeah, negative 624, and then divide by. Make sure this entire thing is in parentheses for it. Because you guys have the calculator. Okay, that entire thing. Yep. Then you do 1 minus. Oops. It just says 1 minus r. Please tell me you guys all get positive 104s. Yes, yes, Kate. What's your question?
I was just saying, just tell him to like the summation. Okay.
Yep, just for the summation. Okay, guys, that's it for today. Guys, I'm going to ask you to please have the geometric series, how to derive it in your notes. Okay, where it came from. This stuff right here, okay, where this came from is important, and I want you guys to understand it. All right, we're going to practice using geometric series for homework today, and that's it. And I'll see you guys tomorrow.
Do you think you could post the slides for how to derive the arithmetic one? I think I missed that.
You know that, I'm going to give it to you
Yes,
guys.
Mr. Kim.
Yeah, no matter what. That's going to be on the slide. But I will post the slides if you need. I think it's necessary.
take my history test for me next period?
I thought you said you're going to ace it. You like Andrew Jackson. Oh, you were being sarcastic? Oh, I didn't catch that. I'm sorry. I'm very bad with sarcasm, so you'll know.
It's okay. It wasn't great. It wasn't great.
It was more subtle.
All I know is
Maxwell, thank you for showing the other way. That was really impressive.
I saw it on my textbook the other day.
Oh, that's how they derived it?
Yeah.
I think your way might be clean. Like, I don't know. It's either way is much difficult. I think they're the same level of difficulty, but I like that one.